Okay, this is compressed by 2a. This is compressed by a. They will arrive at mean position. Okay, they will have velocity. Directly, if you're able to imagine, well and good. So this will have velocity, say v2. They'll collide. So if the elastic collision, right, after impact, how the velocities of the block will be. If the perfect inelastic collision, then what will happen? So first we'll get into the uh, initial 2m v2. What are v2? v2 should be equal to 2a omega 2. Omega 2 should be equal to, first we'll get all the things. Is that okay? 2k by 2m and k by m, both will be same. Both will have same angular frequency. That's the one thing. Next, what about v1? v1 will be a omega 1. Write it omega. Elastic collision takes place. So 2m v2 minus m v1. First, we'll go for elastic collision. 2m v3 minus m v4.
He is asking only time period now, sir. No need of velocities.
The time period of P and Q remains same before. Okay, that one. Elastic collision, okay, that one. Let me just bring V3 and V4, then I'll get into the problem. Huh? Equal to 1 after collision. So I'll assume that. Okay, this the velocities, I assumed it. This will be V4, V4, and this will be V3. V4, this is V3. Quotient of restitution formula. V4 minus of V4 minus V3. Anybody V3, V4 value? Give me V3, V4 value. Solving equation 192. Anybody V3? In terms of A omega, you write it better.
Ninety omega, sir.
How much?
9A omega.
9A omega. Okay. V3. V2, V4. 6a omega. So what we assume the directions correct. So again, you look at this one. After collision, this will have more speed than this. So will they be in contact or they lose contact? They lose contact. No? Is it correct? V3? V3 9a omega, V4 6a omega. Symbols correct, no? V4 2m, MV3. Yeah, fine. V4 minus V3.
Totally, sir.
Correct only. So after collision, what happens? This will have more speed and they lose contact. After collision, so again the time period will be same. So this is about elastic collision. What about inelastic collision?
Get velocity a omega.
If the inelastic collision, so we'll put it 2mv2 minus mv1. For a omega, 3a omega, v equal to a omega. This one they'll move combinedly. No. Okay, now we have some information. Let's take help of this. Then I'll enter into the options. Time period of P and Q remains same before and after collision, irrespective of the fact whether collision between the masses is perfectly elastic. No, a omega is there. Combinedly, what happen again will become 3m, and they're in series 3k. So again will be omega by will be k by m only. So whether it's a elastic or inelastic, the time period will remain same. If the elastic, this will have time period k by, or like omega will be k by m. This will be 2k by 2m. If the inelastic, I'll put it in diagram. So together it will be, so what is in omega dash should be equal to k plus 2k by m plus 2m. Okay, I agree this. So they will have common velocity. Let it be here. So option A is what we can pick up. No, time period of P and Q remains same before and after collision only if collision between the object is perfect. I think I can't pick up this. Only is telling no. That's why I'll not pick up this option B. So option C also only is there, not possible. Only option A I'll pick up. Then if collision is perfect in inertia, amplitude of SHM of combined masses. I think we have information here. Will be A only. So option D also I just covered it. For that purpose I brought here. Can be asked, just be careful in advanced exams. No need of diagram. You could have taught it just by seeing the